say like you didn't have figure. All right, today we're going to be talking about some of the properties of similar triangles. There's certain, trying to ask this question, answer the question, what proportional relationship could form when parallel lines or segments intersect other lines or segments? Learning goal, use properties of similar triangles to find segment lengths, apply proportionality in triangle angle bisector theorems. Okay, first thing, we have what we call the triangle proportionality theorem. I will. Give me just 1 second. Let me get off the phone. Hey, man, you need it. Okay. Wow.
Let me, what if I printed off some stuff and ran it down to you here just a little bit? Be okay? Who do you have? Okay, yeah, let me get their stuff. Is it okay if I get the quiz? Okay, yep. All right, thank you. Okay.
Yeah, here's what you should be writing. Yeah, I will. You need to write down the triangle proportionality theorem. Sorry, Barry. Okay. Sorry. Just this one's a little different, so don't write those words if you started writing them. I really want you to write the figure, or draw the figure, and write the proportion. Okay. That's really how I want you to remember it, more than anything else. I'll read the theorem for you, but see if when you draw this figure, look at this figure while I'm reading this, if this makes sense. If a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. Okay, so if a line is parallel to any of the sides of the triangle and it intersects the other two sides, it will divide it proportionally. How does it divide it proportionally? Well, that's pretty easy. Okay, along those other two sides that it intersects, the distance from A to E over the distance from E to B is proportional to the distance from A to F over the distance from F to C. Okay? Triangle proportionality theorem. Perfect. You make sure you write this down too. This symbolizes that line segment EF is parallel to line segment BC. You see those two vertical lines going up and down? That means parallel to. All right. So I'm going to give you an example and show you this should be, this is going to be relatively easy to see. Okay. All right. Okay. Just kidding. Well, don't worry about this too much. Notice that nothing really changed. I mean, it's the same theorem written the other way. Okay. Think about this. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. Okay? Let's see how there's one side of the proof and then there's the other side. Correct? I gave you in the theorem, I said, hey, if there's a parallel line, if there's a line running parallel to the side of the triangle that intersects the other two lines, it divides it proportionally. Here, what I'm saying is, if the sides of a triangle are divided proportionally in the line that intersects both those sides, then it's parallel. See how you go from one to the other, from A to B, and then use B to get back to A. Yeah, it was on the hypothesis. So that's the point here. The point is that, look, this switched, right? On that prior slide, what is now my conclusion was right here, and what was my hypothesis was my conclusion. Okay, that's why I'm saying it's sort of order. Okay. The symbol that something's parallel is right here. That means parallel. Right? So this tells me that those two lines are parallel. Parallel. That means line EF. Okay. All right. So let's do the example here. Okay. It says it's given that ST sine second ST like that. Must be is proportional to sine second UT. I don't think they're equal, but anyway. So US over RU, that should be parallel. This should be up and down right here. Given that those are parallel, okay? That means that I divide this particular triangle up in segments as a proportion. U to S over R to U would be equal to the proportion of B to T over R to B. Okay? Later, guys, it's pretty boring, right? Because you're just going to set up a proportion and cross multiply. That's all you're going to be doing today. Over and over and over and over, right? Okay, so check it out. When I set this up, I already know that U to R is 14, B to T is 4, and R to B is 10. Okay, so when I cross multiply, I get 10 US, 4 times 14 is 56. After I divide both sides by 10, I'll get 5 and 3 over 5th. I'm sorry, 5 and 3/5, or 5.6 as my particular answer. Same thing we did in the warm-up. Matter of fact, the warm-up problem is how it works, right? Okay, as far as this part's concerned. That's the part we gotta learn. Let's try it. Right here, set up your proportion. Whatever your little heart desires. You. What are you trying to find? Right? Try to find this part right here, B to N, correct? Put X there. Right? Here's the kicker, okay? The hardest problem, the worst thing I can do to you guys, and I'll do it every time. I move this triangle all the way around, right? I can configure this triangle however I need. Okay? And admittedly, that's the difficult part. Where are the parallel lines? Up the top, right? Remember this. If the parallel lines, you can see how these are the parallel lines, right? This side of the triangle is out of play. Okay? It's completely out of play. All you got to do is say, okay, that means that these two sides of the triangle have to be proportional. 3 over x equals the ratio of 2 over 5. Okay? That means 2x equals 15. Oh, I said, yeah, that's right. 5 by 2. 7.5. That's 3 times 5. That's right. I didn't know what to do. So, see what I'm saying? The hardest part isn't cross multiplying. Hopefully we're at that stage yet, right? The hardest part is just setting up our point. That's the part that we got. That's the lesson. That's the learning that's got to take place. Okay. So, because remember our game that we played, little big, little middle greatest, right? Which one of these sides is the littlest? Little. Okay. Yeah. Okay. Over here, which one's smaller? 2 or 5? 2's little. 3, 5's bigger, right? Now go to the other side. Which one do you think is going to be? So you know your edge. Yeah. Yeah. I mean, I can make it really tough and do it like that, but understand, because it's a proportion, it's got to work out that way. Okay? These are parallel lines. So whatever's right opposite of that parallel line, those should be on top of each other. Underneath, where they meet at the angle, those should be on the bottom. All right? You got to work with it. It might not come to you after one exam. Okay? You got to keep working through it. And I will make it harder. Okay? How do I know that these line segments are parallel? So this is the other side of the coin, right? See what I'm saying? It's the other side of the coin. I've now said I'm going to try and verify that DB and BC are parallel. Tell me the proportion I would set up. Remember, little over big equals little over big. Well, so 8 over 12, 10 over 50, 8 over 12, 10 over 50. They produce the same ratio, which they do. That means that those segments are proportional, and if the segments are proportional, then the lines are parallel. Okay? But what we do on that side, they're not parallel. Right? Check it out. If I change this to 13, okay, I don't even know what that ratio would be, right? Right. But I promise you this, if that's 13, that is not 2/3. And if these ratios aren't the same, they aren't equal, then I do not have parallel lines. It can look parallel, it can smell parallel, but it's not parallel. This is that one time in life for you to make that exception. You can't just say, well, I look a lot. Okay? Right? So that's the other side of the theorem. Okay? I love this problem. I love it. Let's do it. Okay. So, get that information. This is a great problem. It's a great problem for us to work through right now. Plug in that information. Think carefully. I would draw this just figure down. Be carefully about what information I've given you. Just like that prior problem I just done, you're trying to prove to me that these two are parallel. That's my question. When I say verify, it means prove it. Okay? Prove it. Okay? 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 I bet you know. All right, let's go from the very beginning. Okay? Let me make sure we understand it. What would verify, what would prove that those line segments are parallel? If the sides are what? Proportional. Not congruent, but proportional. Okay? For them to be proportional, right? Little over big, or the other way around, correct? Right? It has to be like that. L over B has to equal L over B. Let's just call it little and big for now. Okay? We can change our little and big if we need to, right? It tells me that A to C is how long? 36. The whole thing's 36. How far have I gone so far? How many are left over? Oh, 16. So, you messed it up. This is now the biggest side. This is now the littlest side. Okay. All right, switch it up. B over L, B over L. What's BC in total? How many centimeters? 27 centimeters. How many have I given you? 12. I've given you 15, there's 12 left over. Oh, that's what? Big and little. It's okay, guys. The proportion stays the same. The proportion stays the same. You just said it's always going to be little over big. I said I could do that. What I told you is set it up as little over big. Assume it's going to be that. Okay? But the beauty of proportionality is that if you switch both of them, numerator and denominator, it's the same proportion. The proportion remains. Okay? I shouldn't say it's the same proportion. It's going to be a bigger proportion because your bigger numbers are on top, right? But the proportionality remains. The similarity remains. Okay? Here's my proof. 15 over 12, 20 over 16. What do you get? Wait a minute. Put them in your calculators. Everybody should be doing this. You should be using the tools that I give you. Plug those ratios in. What's 15 over 12, Dylan? 5 over 4. What's 20 over 16? Dylan? Anybody? Okay. So what do we conclude, Bo? They are proportional, and since they are proportional, Tyler, what are they? Parallel. See how everything comes together, right? That's an EOC problem right there. You got me? That is an EOC type problem. You will see that stuff on the EOC. That exact same type of problem will be on there. So they're not going to tell you, hey, you need to do a proportion on here, and they're not even going to tell you, hey, this is the distance A to D, right? You have to do a lot of work in there in between to get that set up, right? Okay. So just know I love that problem. Okay. Right. Let's do this. transversal proportionality. Draw yourself some sort of diagram. Don't worry about the, not worry about the definition just yet, okay? I'll read it off to you. If three or more parallel lines, which these are parallel lines. If three or more parallel lines intersect two transversals, then they divide the transversals proportionally. What's that? Okay. Good. Quick example I'm going to show you on this one. Right? But first, let me make sure we understand it. Okay. I've got three, not two, three parallel lines and two transversals. This is why everybody hates geometry, which is fine. Okay. Think about it. The distance from A to C over the distance from C to E is proportional to the distance from B to D over the distance from C to F. Okay? I what numbers in there that we're going to do? Same thing. We're doing the same thing over and over. We're just learning a lot of different ways to do it. Okay? That's all. That's why we've been cross multiplying like mad at recently. All right? Three. This is like the roots of geometry. Okay? All right, look at their art application. We love doing these things because you think about word problems and real life application, and this is what math teachers think of when they think this is real life. Suppose that an artist decides to make a larger sketch of the trees. Okay? In the figure, if AB is 4.5, A to B is 4.5, B to C is 2.6, and C to D is 4.1, K to L is 4.9, what would L to M be? Then what would M to N be? See, patient. Okay, let me go back. Where are my parallel lines? Yeah, trees, very good. Here are the parallel lines, correct? Actually, I got four of them here, DJ. Okay? If those are the parallel lines, then I got a news for you guys. Here are the proportions. Okay? This should be 4.5 over 2.6 equal to 4.9 over whatever delta M is going to be. Okay? 2.6 times 4.9. Not very big, you don't have to write it down. 12.74. 4.5x. DJ, are you right? 2.83. Okay. 2.83. I could do the same thing if I wanted to find M to N. I don't want to find it right now because I already broke down. Right? So those aren't too bad either, right? Just the same, again, we're doing the same stuff over and over. You just got to be able to visualize and see where is the proportionality going to come in. The temptation might be here over here, right? Not it. Okay. All right, one last one. It's called the angle bisector theorem. It's very important. Very important. Okay, on this one, I want this. I want you to write down. Let's do this part. We'll keep it the same today. Okay, keep it the same. Sorry, I hope you. Right? An angle bisector of a triangle. First off, what does an angle bisector do to an angle? Divide it into two not sectors. Two what type of angles? They could be obtuse. I could have, think about this. I could have a 300-degree angle. Okay? And I take an angle bisector of that. Equal or congruent angles, right? Okay? That's key. Okay? An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. All right? When I take that angle bisector, the distance from B to D over the distance from B to C is proportional to the distance from A to B over the distance from A to C. It's the toughest one that we do all day, right? It's the toughest one we do because it's the hardest one to remember. Okay, just remember, you trace down that angle bisector. It's going to split this in half. Not in half, but whatever. Okay, we'll call it little and big because y'all like little and big. It doesn't. Check it out. It doesn't have to be L over B. But if it is L over B, we keep those the same. And you got to quit thinking about it in terms of what are the numbers that are going to go in there. Start thinking of it in terms of how proportionally would I divide this. Here's how proportionally you divide it. The blue side should be on top. The red side should be on bottom. Okay? I don't care if this side ends up bigger than this side, that's fine with me. Okay? But as long as B to D is on the top, and D to C is on the bottom, we're okay. But if I split it that way, the same side length, A to B, has to be on the top, and A to C has to be on the bottom. Okay? So to help out our big little computer. Right? Here would be an example. Let me show you how to even set it up. Okay? If Q to S is an angle bisector. Sorry, filling your break. Okay, if Q to S is an angle bisector, think about this. Okay. X over 2, we're going to put it on top, right? We're going to put it over the other part of the bisector section, which would be this. X plus 5. Okay. X minus 2 meets this side length, BQ, correct? It also has to be on top. Okay? X plus 5 meets with that side length, 40, it's got to be on top. There's your proportion. Yeah. From there, it's just like warm up. So you're probably minus